comprehensive live learning platform, that is BYJU'S Exam Prep. So how are you all guys? Welcome to the today's session on traffic flow characteristic. Very important session guys. Join fast quick everyone. So this is the last session for this traffic engineering series for this Mastering GATE 2023, and I have covered some of the very important topics which are asked in the GATE 2023 examination. So if you are following my series of traffic engineering, if you have attended all the sessions, then you might have got a very good idea of traffic engineering as a whole, and some of the very important topics are completely covered in this series over here. In the today's session, I'll be discussing one more very important concept from where repeated questions are asked in the GATE examination every year. You will find similar kind of question every year which is asked. Very good evening everyone. So that is why today's session is going to be a very important session for each and every one of you. Attend the whole session from the starting till the end, okay? Because there are some topics from where the GATE has not touched till now, but there is a probability that those topics will also get touched in the coming years. So there is a possibility that a question may be asked from those topics also. Okay, so up till now they are only asking questions from only one single topic. I am covering two other topics also, so you will get a very good idea of the whole topic in the today's session. So welcome everyone, quickly join fast. We are about to start everyone. Are you all ready to learn something new today? Are you all excited to learn something new today? How are you all? How are you all guys? How are you all? Are you all fine guys? Are you all ready to start with your GATE 2023 preparation? How is your preparation going on? And how many days it has been since you have started your preparation? So are you all excited for the GATE 2023 examination that is yet to come? And what is your aim for GATE 2023 everyone? What are you aiming for in GATE 2023 guys? Tell me everyone. Tell me everyone. I am also fine, Anji. What is your aim for GATE 2023 everyone? What are you aiming for? When you say that I want to appear for GATE 2023, what are you aiming for? Yes, everyone. Tell me, guys. Always aim for the best, everyone. Always aim for the best. When you're preparing for any examination, always aim for the best. Believe in yourself and believe in yourself that you can excel in any examination. Always aim that you're going to score an All India rank of 1. Prepare in such a way that you are prepared to score All India rank 1. So your aim should be such that only. How can you enroll to the BYJU'S classes in app? Anji, we will definitely take your follow-up, okay? You can either visit our BYJU'S Exam Prep app. Okay, we have a BYJU'S Exam Prep app. You can visit over there. Over there you will be guided how to subscribe. Okay, anyways, I'm also going to give a follow-up. So most probably the team may also I will see if it can be followed. It can be if it can be referred further. Okay, if your doubt can be clarified over there. So anyways, you will also get your solution at the BYJU'S Exam Prep app also. So starting with the today's session, very important session. I will not take any of your more time. Okay, so firstly, you all know me. My name is Rohan Goyal, everyone. And you will also get the PDF of the today's session on my Telegram group, Civil by Rohan Goyal. If you have not joined my Telegram group yet, search Civil by Rohan Goyal, and you will find my Telegram group over there, and you can join my Telegram group. You can also use this link over here in order to join my Telegram group. So the most important part of my Telegram group is I provide personalized Zoom doubt resolution. Okay, so personalized Zoom doubt resolution is provided over here. So you can ask me to take a Zoom doubt session and I will definitely arrange one. Okay, moving on. Now in the today's session we are going to be studying what are traffic flow characteristics. Okay. What are traffic flow characteristics? Macroscopic characteristic, and we are going to study these three models: green shield model, Greenberg model, and exponential model. Up till now, GATE is only focused to the green shield model. GATE focus is only to the green shield model. It has not touched these two models, but I am expecting it is going to be touched in the coming years. So that is why I have covered these two models also in the today's session. So we are going to discuss these two models also in the today's session. So first of all, what are traffic flow characteristics? Traffic flow characteristics are broadly classified into macroscopic and microscopic. So these are two different topics, okay? In the today's session, I am only going to be covering macroscopic characteristics. Microscopic characteristics are going to be covered in a separate session in the coming days, right? So I will be planning more such sessions like this, and I will be taking this topic also over there. What is microscopic characteristics? Macroscopic characteristics in a traffic flow refers to traffic volume, traffic density, and your traffic speed. Now the relation between these three is Q is equal to KV. This is your traffic volume. It is represented in vehicles per hour. This means if you stand at an intersection, how many vehicles are passing that intersection per hour? Number of vehicles passing an intersection in an hour. This is traffic density. This is traffic density in vehicles per kilometer. If you take one stretch of a road, 1 kilometer stretch of a road, if you take a 1 kilometer stretch of the road and if you count the number of vehicles in that 1 kilometer stretch, it gives us the density of the traffic. That is vehicles per kilometer. And this is your speed, that is kilometer per hour. So if you see, the units are also balanced. Vehicle per kilometer into kilometer per hour, kilometer cancels out, it becomes vehicles per hour. So the units are also satisfied over here. Is it clear to all? Any doubt up to this point? Are all the three characters are clear to you? These three terminologies, any doubt to anyone? What is traffic volume? What is traffic density? What is speed? I hope it is clear to you. Any doubt to anyone? Traffic volume is number of vehicles passing a given intersection. Okay. Traffic density is number of vehicles in a given stretch of road. Speed is the speed of the vehicle. Right? Alright. Now, the first is your green shield model. In the green shield model, the relationship between speed and density is assumed to be linear. As shown over here. Your density and speed relationship is linear. And this relationship is V is equal to VSF 1 minus K upon, or let us derive this, okay? Let us derive this, okay? Because we are here to understand from the basics, right? Let us understand this from the basics only, okay? Let us say that your velocity, is equal to A plus B times density. Now what will happen if your density is equal to 0? What does this mean? Density is equal to 0 means that when you take a 1 kilometer stretch of the road, there is no vehicle at all. When you take a 1 kilometer stretch of the road, there is no vehicle at all. That means vehicles are moving at a free speed. So your velocity will be equal to VSF, which is free mean speed. That means your vehicles are moving at a free speed. Okay, there is no jam, there is no density, there is no congestion. Vehicles are moving freely. So your V will be equal to VSF. Alright. So when you substitute this, it will become V equal to A, so plus B into 0. So V will be equal to VSF, which is equal to A. So A becomes equal to VSF. Alright. Second condition would be, what would be the second condition? Now, so when your K is equal to 0, V is equal to VSF. Alright. Now, when your V is equal to 0, what does it mean? When your velocity is equal to 0, when does this condition occurs? When there is a jam on road. When there is some jam on road. So the density is referred to as the jam density. Now all the vehicles are in the stopped position. Maximum the vehicles have occupied the maximum, the one stretch of the road, 1 kilometer stretch of the road has been occupied by the maximum number of vehicles. All the vehicles are in the jam condition. So the density is referred to as the jam density. So when velocity is equal to 0, K is equal to Kj. So substituting this over here, so when V is equal to 0, A value is VSF plus B times Kj. So from here B will come out to be equal to minus VSF upon Kj. Any doubt to anyone? Any doubt up to this point to anyone? Any doubt up to this point to anyone? So substituting the value of A and B. Substituting the value of A and B. Substituting the value of A and B in the above formula, you will get velocity is equal to VSF minus VSF upon Kj into K. So if you take VSF common, your equation will become V is equal to VSF 1 minus K upon Kj. Any doubt? So this is your relation between velocity and the density. This is your equation of this line. This is the equation of this line. Alright. Now let us find the condition of the maximum flow. At what is the condition to have a maximum traffic flow? What is the condition to have a maximum Q value? So what is Q? Q is equal to KV. So Q is equal to KVSF 1 minus K upon Kj. Put the value inside. Q is equal to VSF 1 K minus K square upon Kj. Now for the maximum condition, for Q to be maximum, dQ upon dK should be equal to 0 for Q max. Right? So dQ by dK will be equal to how much? VSF into 1 minus 2K upon Kj. And this should be equal to 0. And when you substitute this equal to 0, when you substitute this equal to 0, see VSF will go down. So 1 minus 2K upon Kj will become equal to 0. So from here your K will come out to be equal to Kj by 2. For maximum Q max, your K is coming out to be equal to Kj by 2. Any doubt up to this point? Any doubt to anyone up to this point? Tell me guys. Any doubt up to this point to anyone? Yes guys? Is it clear to all? Now substitute this value. Now substitute this value in the above formula. K is equal to Kj by 2. Kj by 2 upon Kj is 1 by 2. 1 minus 1 by 2 is 1 by 2. So V will be equal to VSF by 2. So Q max. What is Q max? Q max will be equal to K into V, that is Kj by 2 into VSF by 2, which is equal to Kj into VSF by 4. This is your Q max. Tell me if there is any doubt to anyone. Is it clear up to this point? So from this page only you will find repeated questions. Repeated question, guys. Repeated question. 1 year they will ask what is free mean speed. Another year they will ask what is jam density. Another year they will ask what is maximum traffic flow. Another year they will ask what is velocity at the maximum traffic flow, Vs by 2. What is the density at the maximum traffic flow, Kj by 2. This type of questions may ask. And if they want to ask a little tougher question, they will ask from this graph. Now let us draw the graph over here. So this is K, this is V. What is this value over here? When density is equal to 0, velocity will be free mean speed. And when velocity is equal to 0, density will be jam density. Okay. Now let us draw the graph between traffic flow and your velocity. Okay. Now when velocity is 0, your traffic flow will also be 0. Your traffic flow will also be 0. If velocity is 0, that means the traffic is not flowing. The number of vehicles which will be passing an intersection, vehicles per hour, the number of vehicles which are passing an intersection will be 0 if the velocity is 0. And if the velocity is equal to VSF, that is free mean speed, in that case also the traffic flow will be almost equal to 0 because you will be waiting or there is no traffic at all. Okay, the road is empty, you will be waiting, the density is 0. There will be no vehicle then also which will not be passing the intersection. So then also the traffic flow will be 0. So this is a parabolic relationship. If you see over here, this is a parabolic relationship. K minus K square upon Kj. This is a parabolic relationship. So the maximum density is observed when velocity is equal to, maximum density is observed when VSF is equal to VSF, velocity is equal to VSF by 2. So it will be obtained like this. So this is Q max. Any doubt to anyone? Any doubt to anyone? Any doubt to anyone? Similarly, when you draw the density versus traffic flow curve, density versus traffic flow curve. Now when density is equal to 0, density is equal to 0 means there is no vehicle in 1 kilometer stretch. That means the traffic flow will also be almost equal to 0 because there is no vehicle moving. Okay, if you will be standing at an intersection, you will not see any vehicle at all. So this will be 0. And if density is equal to Kj, then also there will be total jam condition. You will be standing at an intersection and you will be finding that all the vehicles are in a jam condition. There is no vehicle passing. So then again the traffic flow will be 0 and it will be maximum. The traffic flow will be maximum when the density is equal to Kj by 2. So the curve will be like this, somewhat like this, parabolic in nature again, and this will be Q max. Any doubt up to this point? Are all the relationships between traffic flow, traffic density and velocity clear to you all according to the green shield model? Is it clear to everyone according to the green shield model? Any doubt up to this point, you can ask me. If there is any doubt up to this point, you can ask me, guys. Yes. So this is the most asked topic in the GATE examination. You will find questions from this topic. You can go to the previous year question, check the previous year GATE questions. You will find each year one question from this topic. You are scoring 2 marks from the today session in the GATE examination. In fact, from each and every session that I have taken today, you have secured about 6 to 8 marks already in the GATE examination if you have watched my whole series, right? So you have already secured 6 to 8 marks in your GATE examination, and that is a very, very, very big amount. Okay. Explain condition 2 and 3. All right. Condition 2, these two. Condition 2 and 3, you mean these two? Anji, these two graphs we are talking about. Condition, what condition? These two conditions. What condition are you talking about? Graphs or conditions? Are you talking about graphs or conditions? Graphs, right? All right. So, okay. So over here, this is the normal graph between density and velocity. So this is linear, as over here V is equal to VSF 1 minus K upon Kj. So this is a linear relationship. When density is equal to 0, velocity is equal to VSF. And when velocity is equal to 0, your density is equal to Kj, that is jam density. Now let us plot traffic flow versus velocity curve. Now when velocity is equal to 0, that means your traffic flow is almost 0. And when velocity is equal to free mean speed, that is VSF, that means again the traffic flow is almost equal to 0, right? Because there is hardly any vehicle which is passing an intersection. Okay. So the maximum traffic flow is obtained when V is equal to VSF by 2. Maximum for Qmax. For Qmax condition, for Qmax condition, अरे यार, what should I do? What highlighter should I use? Red. Let us take red. Okay. For Qmax condition, maximum velocity is equal to, your velocity should be equal to VSF by 2. So at VSF by 2, you are getting Qmax at this particular point. And similarly in this graph over here, your Qmax is obtained when density is equal to Kj by 2. So over here also at Kj by 2, you are getting Qmax. Is it clear to you all? Is the graph clear to you, Anji? Now, any doubt to anyone now? Is there any other doubt to anyone? Shall we proceed? Shall we proceed? Yes or no? Is the graph clear to all? All right. Very good. Now we are going to talk about Greenberg's model. Now in the previous model, the relationship was assumed to be linear, but in this model, the relationship is assumed to be logarithmic. So I will give you the relationship. The relationship is V is equal to VSF ln K upon Kj. Now this is as per Greenberg. This relationship is as per Greenberg. But there are other models also. It is not necessarily only these 3 models are there. There are other models also. So in the examination, you may be given some random equation over there. So now you need to understand how to find out the maximum flow. Okay, which you already know. We are just applying the concepts which we already know. So over here, you need to find out what is the maximum flow. So the velocity equation is given to you, which is logarithmic equation. Now, what is traffic flow? It is equal to Kv, which is equal to K times VSF ln K upon Kj. Okay, now for maximum flow for Q max, dq by dk should be equal to 0. Now let us do dq by dk. dq by dk is equal to, so dq by dk, it will be VSF common. VSF common. First we will differentiate k and we will keep this as like this, ln of k by kj. Then we will keep this as constant plus k and we will differentiate this term ln k by kj. So 1 upon k by kj, and then we will differentiate this, that is 1 upon kj. So this will be like this. Okay, so this will cancel out. K, this will come 1. This will kj cancels out. Okay, k into kj by k or k by, oh yeah. So this is actually my mistake. This is actually kj by k. This is not k by kj, this is kj by k. That's why I was getting wrong over here. This is kj by k, kj by k, kj by k. So k 1 upon kj by k, so it will be k square. Now differentiation of kj by k into minus kj, like this, right? So kj cancels out, k will come up, will cancel out with this k, and this is also cancelling out. This goes up, k square is cancelling out, so minus 1. So it is coming out to be equal to, so this will become equal to 0. VSF ln kj by k minus 1. So when this is equal to 0, VSF will be 0. So ln kj by k will be equal to 1. So kj by k will be equal to E, which implies your k is equal to kj by E. At Q max, k is equal to kj by E. At Q max, k is equal to kj by E. Is it clear? Now substitute this value in this equation. K is equal to kj by E, so it will be ln E is equal to 1, V will be equal to VSF. So V equal to VSF ln kj divided by kj divided by E, right? So kj cancels out, ln E will be equal to 1, V will be equal to VSF. So Q max will be equal to how much? Q max will be equal to how much? K into V, that is kj by E into VSF. So VSF into kj by E. So this is your Q max. Any doubt? So you can find out Q max by this relation like this. Okay. Now why this model is not very popular is because if you put over here, if V is equal to 0, okay, 1k will be equal to kj. Okay, then if k is equal to, if k is equal to 0, if you put k is equal to 0 in this equation over here, what will happen? Kj by 0, so it will become infinite. Ln of infinite is not defined, so velocity is not defined. So there is a drawback to this equation over here. The drawback is at k is equal to 0, V is not defined. Is it clear to all? Any doubt up to this point to anyone? Can you find out Qmax if any other equation is given to you? Can you find out Qmax or velocity or density at Qmax if any equation is given to you? Can you do the simple mathematics, everyone? Yes or no? If such a kind of question is asked to you in the GATE examination, will you be able to solve this question? Yes, everyone? Yes, everyone? Will you be able to solve this question? Okay. If yes, now I would like you all to solve this next equation, which is as per the exponential model. Now in the exponential model, the relationship between k and v is assumed to be exponential in nature, as shown like this. So v is equal to VSF e to the power of minus k by kj. Now if you know how to solve it, start solving, everyone. Now start solving. Start solving, everyone. Start solving and tell me what is Qmax. What is Qmax? Tell me what is Qmax. Take your time. Take your time, everyone. Take your time and tell me what is Qmax. Start solving. Now this is the time for you to use your pen as much as you can. Now how many of you were writing along with me? How many of you were writing along with me? How many of you were writing along with me? Now if you like the session up till now, guys, definitely do click on the like button and share the session as much as you can, right? And click on the subscribe button to the BYJU'S Exam Prep. It is very important because it gives us a lot of happiness, and we think that the content that we are delivering to you is liked by you guys. Okay, then only we get some confidence, right? Otherwise we feel that we are just doing mindless efforts which are not putting any good, which are not going to the good end. Okay, so definitely do click on the like button and share the session as much as you can, and do not forget to subscribe to the BYJU'S Exam Prep if you want more such informative sessions. If you want to get an edge in the examination through our guidance, so you can be a part of BYJU'S Exam Prep team. Okay. What is Qmax? So you are busy finding out what is Qmax. Now you have seen how to do it, right? Now you have seen how to do it. Very good. Very good. Any answers? Any answers? Take your time, no problem. Okay, this is something that you're doing for the first time. Okay, and more is the difficulty that you face during the starting, more you try to crack the problem, the more better it will be for you at the later stage, right? The more you are going to use the pen today, lesser you will be using it in the examination. Okay, see the shortcuts you asked, right, to our faculties, sir, tell us the shortcut, how to do the shortcut, tell us how this problem can be done in a shortcut, right? There is no such shortcut. Okay, there is always practice. Now suppose if a particular problem requires 4 to 5 steps to solve, if in a problem you are required to solve that problem in 4 to 5 steps, now if you are practicing a lot, you have done those kind of problem number of times, what will happen is out of those 4 or 5 steps, 2 to 3 steps you will be automatically able to do, in the back of your mind. There will be calculation going on in the back of your mind. Your equations are going to be, you are going to see the equations in your mind. You are going to put the values in your mind in the equation itself automatically. This is not something that you are putting some effort to do. This is happening automatically because through practice, it has become so easy for you that now you are not even conscious that you are doing it. Do you remember when you started driving for the first time? When you were driving for the first time, you were very conscious. You were continuously, your eyes were on the road. Okay, you were taking care of each and every thing that was passing through you. Okay, each and every vehicle, each and every obstacle, each and every animal or whatever it may be, each and every object, each and every pothole. You are taking care of each and everything. And now when you have driven for so many times, now you are so fluent in driving that you need not focus upon all those things. Those things comes automatically. Whenever you see a pothole, you don't even realize that you have taken a turn in such a way that the pothole has been missed. It has become automatically. And how it has become automatic? Just because of your practice. Okay, no one has given you any shortcut to drive. You were able to drive that fluently only because you had practiced it a lot. Similarly, over here also it demands practice. Mean speed into mean density, Qmax. All right, let us calculate. Okay, let us calculate. All right. So, what will be your traffic flow? It will be equal to kV, which is equal to K into VSF e to the power of minus K upon Kj. Okay, now for Qmax, dq by dk should be equal to 0, which implies your dq by dk equal to VSF common, K differentiation of K will be 1 e to the power of minus K upon Kj plus K constant, differentiation of e to the power of minus K upon Kj into minus 1 upon Kj. Okay, now this becomes equal to 0. This becomes equal to 0. So when you equate it equal to 0, so VSF will go, E minus K upon Kj and E minus K upon Kj will go to 0. What we are going to be left with? What you are left with? 1 plus or minus 1 minus K upon Kj equal to 0. So K will become equal to Kj. K is equal to Kj. Now substitute this value over here. Now K is equal to Kj, e to the power of minus 1, V will be equal to VSF by E. Okay. So Qmax equal to Kj into VSF by E. So the Qmax will again came out to be same as that of the previous case. Both are giving us the same value. Both are giving us the same value. Okay. So good try everyone. Good try. Very good. So both are giving us the same value. So what is the drawback in this case? Drawback is what is the drawback? Now if you put V is equal to 0, if V is equal to 0, if K is equal to 0, then this will be equal to 1, no problem. If V is equal to 0, e to the power of minus K upon Kj is equal to 0, ln of 0 is not defined. Right. So at V is equal to 0, your density is not defined. Okay. At V is equal to 0, your density is not defined. At V equal to 0, K is not defined. Is it clear to all? Any doubt? Okay. Okay. Clear? Yes. So with this, we wind up our today's session, everyone. Thank you, guys. And if you like the session, do share the session, everyone. Click on the like button. And I'm going to be coming up with more such sessions for you guys, more such informative session. Do not forget to subscribe to the BYJU'S Exam Prep app and our YouTube channel, and click on the like button and bell icon for more such informative videos, everyone. Thank you, guys. Take care and see you in the next session, guys. Bye, everyone.